I'd like to welcome everybody to today's webinar. My name is Matt Henderson, and I am a consultant with the Energy and Manufacturing Project in Appalachia. You do see we have the website listed on the screen here today. So this project is focused on working with manufacturers, helping them engage in the energy supply chain. And today's webinar, we're going to focus on the opportunities in the RNG space, specifically around the anaerobic digester. So on your screen, you'll see upcoming webinars that we have, one on focused on geothermal, and then November 20th will be our fourth one on AI data centers. And then in December 18th, we'll have opportunities in solar, and we're focused on where the solar industry is in today in 2026. So again, take a look at the screen. When you do click on that link there, and Matt, if you could go to the next slide, you see each of our energy segments that is focused on. We have information about the market size, the market drivers, some of the key developers, some trade groups. It's a quick snapshot to take a look at the industry, see if it's an opportunity for your business, and to learn more about it as a good starting point. And as we go to the next slide here, just introduce today's topic. It mentioned you can click on all of these links. I will drop the link to download today's report. But today we're going to focus on the RNG and specific to the anaerobic digesters. And we're pleased to have with us today Matt Spetz with the Penn State Extension Energy team. And Matt's going to talk a little bit about their research and what they found. And Matt is an extension educator with the extension team, and his focus is on land use and local government considerations. So, Matt, we're pleased to have you here today. As you go through your slides, I'd encourage anybody, if you do have questions, to submit those in the Q&A pod. We'll cover those at the end of the presentation. We did receive a few, which Matt's going to cover in the presentation. So, Matt, with that, I'm going to ask you to take it away, sir.
All right. Thank you, Matt. So I'll be covering our biogas and RNG industry overview. As Matt said, I am a Penn State Extension educator. I also am a member of the Sea Change Grass to Gas team, which is a research team focusing on innovations in anaerobic digestion, and also with a focus on taking biomass such as grass and incorporating it into anaerobic digesters to produce biogas and RNG. So with that, to first go over, in case anybody needs to know what is biogas. So mainly it's methane or natural gas. Depending on the method and the feedstock used, it's anywhere between 45 and 75% methane, which is the useful part of the gas. In an anaerobic digester, this would be achieved either taking something like wastewater or in agricultural digesters, taking manure, putting in a digester, which is a tank which incorporates a microbiome, which takes that feedstock and converts it into biogas. The rest is mostly carbon dioxide and then other traces of water, hydrogen, and other non-productive gases. So you can either burn it as biogas, filtering out some of the sulfur that might corrode the electrical equipment, or you can filter out all the different kind of useless gases and upgrade it to RNG, which is renewable natural gas. So what does kind of the potential of this industry look like? Well, right now there's about 40 billion cubic meters of natural gas equivalent of biogas produced globally, and about 10 billion cubic meters of natural gas equivalent of renewable natural gas. This equates to about 3% of your global bioenergy production, though that is a rapidly growing amount, and about 1% of your global natural gas production. And according to IEA, between the various different potential feedstocks, such as manure, crop residues, and the such, there's potential for over about 100 billion cubic meters of natural gas equivalent, which would, I'll go over this later, but about 10% of the current US natural gas demand. So what does the market size look like right now? Well, there's about 2,500 biogas sites in the United States. A lot of those are the highest area where this concentration is California. And then you see other larger concentrations in the Northeast, Midwest, and Southeast, where there is a specific density and size to kind of agricultural sites, wastewater treatment facilities. And generally speaking, that's the largest use is wastewater treatment right now with 1,180. You also see landfill gas recovery sites, which don't use digesters, but instead take advantage of the natural gas production that occurs in landfills with anaerobic conditions or conditions without oxygen, and then collects that biogas. Or you see farm digesters, which is about at 609. And right now, the current market size estimated by Granby Research is about 6 billion for the U.S. biogas industry and about 1.76 billion for the U.S. RNG industry. Potential growth. Well, American Biogas Council also projected how many potential projects might be feasible in the U.S., and they came up with a large amount of farms, over 11,000 farms for their waste products, 3,750 potential sites for wastewater treatment plants, about 730 more landfills. And also a growing use case is food waste only digesters, which could grow, are about right now at maybe 100 and could grow to 1,370. And we see this projected growth for biogas is about a steady 2.7% until 2030 by Granby Research. And the RNG market has a lot more explosive growth from a small start at about a projected 13.7% compounded annual growth rate, to make that clear for both. And just to highlight this kind of explosive growth that we see in renewable natural gas projects, this is a chart from the RNG Coalition showing this huge uptrend in the amount of projects you're seeing here in North America. I think American Biogas Council put in 2024 that the number of biogas and RNG projects, about 95% of that total were RNG projects. So we're really seeing this new emphasis on RNG production versus biogas, which is used to generate electricity. So one of the biggest drivers, and we'll get into a few others, is this bipartisan support. So this is actually a picture from the House PA House Energy Committee having a joint session touring Rhineford Farms, where both sides are, for their own reasons, kind of interested in digesters. On one side, you have its ability to reduce carbon emissions. This is due to the fact that they're taking methane emissions that might happen on farm from a lagoon storing manure or from a landfill emitting methane, which has a very high potential for global warming. They're capturing it and then burning it, which converts it to carbon dioxide, which with a much lower potential for global warming, therefore reducing those emissions. On the other side, you have things like ag security and energy security. So it's a domestic product for energy, and on the ag side, it is an incredibly good opportunity, especially for farms to kind of diversify their revenues while producing energy on farm. So both sides kind of have some level of interest on the national level. We saw the IRA produce some key incentives, either through providing additional funding for the Renewable Energy for America program or through access to investment and production tax credits. And we saw the One Big Beautiful Bill maintain these tax credits as well as expand the clean fuel production tax credit 45Z, which has been pretty well favored by the industry. So, or is favored now by the industry. So, a lot of excitement and kind of this bipartisan support here. Key drivers of biogas and RNG growth. So one of the biggest ones I've seen lately is this kind of advancements in food waste processing. So as I mentioned before, you're seeing increased interest and potential for food waste process or food waste only digesters. Now, we've done this research here on our own team. Plenty of research papers have kind of gone over, as you can see here in the chart, this increased production based on how much food waste is incorporated um, versus manure or wastewater. And this is due to the fact that manure or wastewater is coming from already pre-processed or, digested materials, which makes it a lot easier to work with in a digester, but also has already utilized some of that energy. Incorporating food waste adds feedstocks that have that energy. Why it hasn't been more incorporated before, though, is because it adds complications to the chemistry inside that digester. The microbiome that is producing the natural gas is sensitive, and food waste makes it a lot more complicated to manage. But we've seen advancements in sensor technology to give real-time updates in the digester, advancements in kind of this data-driven approach, which allows quick reactions to any changes in the digester, which then can be accounted for, preventing things like foaming events or other kind of complications that might slow production. I already covered kind of government support both on the federal level and then on the state level. Things like the renewable fuel standards or the California low carbon fuel standards have been a great support to the RNG, especially. There's also an emphasis on generating co-products with these sites. I've talked to producers who, especially with anaerobic digesters, have kind of shifted more interest in nutrient collection, both from the food waste and manure, collecting nitrogen or phosphorus or other soil amendments, which can be sold as products to agricultural producers, is a very interesting use case. And then it is also a clean solution for hard to decarbonize sectors. So, unlike other solutions such as hydrogen or electricity, RNG is pretty much the same as natural gas, it's just produced renewably, which means that it can then pretty much be used in all the same infrastructure that a lot of these hard to decarbonize sectors have without really much in the way of actual adjustments. Make it an easy solution, say for steel making. The maritime industry has shown some interest in um, liquefied renewable natural gas. And then some additional tailwinds. You have organic waste reduction laws. All the states in green here have these laws. So a few in the area, such as New York and Maryland, which provide anaerobic digesters as a solution to divert the organic waste from landfills to their sites to be recycled. And also the community digester model is one that's been brought up. We have a project here led by Air Liquide in actually Homer City or near Homer City, which is a digester that will be um, working with I think 19-20 different farms to take off their manure and produce RNG through it. So interesting things. What are some of the biggest hurdles? Well, you have competition with natural gas and renewables. So as you can see here from the chart of comparing the potential USD per gigajoule of potential sites compared to gas prices in different parts of the world. For the US, it's about 4 USD per gigajoule is the wholesale gas price. And when we look at North America, the lowest get down to 8 or 9 USD per gigajoule. So without these kind of incentives or goals for decarbonization, it isn't competitive for electricity production. Well, it is offers a lot more reliability than renewables. The levelized cost of energy is much lower for renewables as well. The core technology as well is already mature. Now there are a lot of opportunities and kind of this access to new feedstocks, new advancements in sensor technology to manage these digesters, as well as, this generation of co-products. But at the core of the technology, it's fairly mature, and it's hard to take advantage of economies of scale as much as other technologies, given that each project is a somewhat bespoke in nature, meaning it's hard to really build out one from the other. Others we've seen here is gaining the social license to operate from communities. Generally speaking, when it's just a farm, putting in a digester, it's usually acceptable, but with some of these larger projects and projects taking on food waste, we have seen some community opposition to bringing in food waste or concerns about nutrient runoff. If some of the digestate that is coming out after it's processed, after the manure is processed, is applied on land. Complications with permitting regulations. Given this is both an ag and industrial use, you have a variety of permitting requirement and regulations from a variety of different entities. So the just sheer number of entities you're trying to get different permits in, from whether it's permitting for food waste, permitting for air emissions, permitting for applying some of that digestate to the land and how that changes a farm's nutrient management plan. A lot of different moving parts. And then finally, just as I mentioned before, the overall potential of the market is limited because you're taking waste products, which are limited in themselves. There's only so much that makes sense to use. So depending on estimates, it might be somewhere between 10 to 14% of North American natural gas demand could be met. Now, I won't get too lost into details, given I mentioned before that these projects are all bespoke. There's a lot of different design systems. But to give you a few ideas of the core components of a digester, obviously moving the digestate liquid slurry around requires usually hydraulic pumps to move the digester through the system. Heating equipment, due to the chemical and biological processes, you generally need to heating equipment in order to kind of maintain operating temperatures that allow the reactions to happen. For most digesters, this is usually around maybe 86 to 88 degrees or 95 to 100 degrees, depending on the type of digester. Motors, not all digesters incorporate motors, but we're seeing these a shift to kind of agitate the digestate, make sure that there aren't parts of it that are solidifying at the bottom, and to encourage, these biological reactions. And then finally, the digester tank, which can either be metal, or we've seen concrete tanks designed, which are meant to contain the digestate for the extended period of time that it is going. Now, there's also landfill gas recovery systems, which use piping to collect the gas and covers to contain the methane, use pipes to and pumps to capture that natural gas producing in the landfill. We've also seen plug flow digesters, as well as more fast acting wastewater treatment digesters. So, and then finally, we kind of have this upgrading biogas to RNG part of it, which generally speaking, the upgrading techniques, there's a lot of ways you can do it, but they're generally effective to get biogas up to pipeline standards, up to this really high methane content. So for simple methods that are more geared towards filtering out sulfur for electricity production, you might see something like iron sponge filters. You also see chemical solutions applying different chemicals to the digestate and slurry itself that filter out, say, hydrogen sulfide, chemically reacting with it, removing it from the overall equation. And then you see other things like pressure swing absorption systems that are meant to filter out these various compounds. So you're generally trying to filter out carbon dioxide, oxygen, um, water, vapor, and especially hydrogen sulfide, which is corrosive to materials, definitely needs to be removed. Um, Finally, we kind of see also this commitment to decarbonization goals. So one example would be a deal between Vanguard Renewables and AstraZeneca to procure about 650,000 MBTUs per year for about 15 years or more. Or Align RNG, which is a collaboration between Dominion Energy and Smithfield Farms, to develop about $5 million worth of projects to provide RNG to Dominion Energy to meet its decarbonization goals. Um, Other project developers, big ones, Clean Energy Fuel Corp, Archaea Energy, which specializes especially in landfill gas recovery systems to produce RNG. I mentioned Vanguard Renewables. And then you also have your players in the biogas, upgrading biogas, electric equipment producers. Air Liquide is both kind of a project developer, but they also specialize in selling RNG upgrading equipment, as well as Greenlane Renewables and Malberg Water. AB Group has traditionally been producing the combined heat and power systems for these projects that they use, but have also kind of got into the RNG upgrading and liquefying natural gas components of it. And 2G Energy is one of the biggest kind of electric CHP producing electrical equipment producers in Europe for these systems. And what do we see kind of expected future growth? Well, we have two kind of scenarios, one more aggressive, one less aggressive. The STEP scenario is pretty much taking in kind of the factored policies around the globe and what those policies would lead to. Well, the APS is kind of if countries met all their pledges for decarbonization and incorporating these systems, what would that lead? So on the less aggressive growth curve, which is just the current policy, about we could see global production boost by about 4% per year between 2023 and 2035 globally. And RNG demand with its given rise, we could see it expected to grow 5 times under the less aggressive scenario and 10 times under the more aggressive scenario globally. Europe right now is the most mature market, and by IEA's projections, could reach nearly half of their natural gas demand produced by RNG by 2050. Right now, Denmark, I know, is the closest to that mark at about, I believe IEA put them at about 40% of their current natural gas demand. And China and India are kind of emerging markets that have a lot of potential given just the overall availability of different waste products, whether it's agricultural and the like, and kind of their policy pushes towards implementing biogas and RNG projects. So those are expected to have some rapid growth here in the future. But with that, I think I'll open it up to questions.
Okay, thank you, Matt. We did receive a few questions, so again, encourage anybody, if you do have some, to please submit them. So first question comes in. It says, what kinds of food waste is practical for digesters and how much? Maybe I think they're asking like percentage wise.
So yeah, I mean, I've seen advancements both kind of what food waste can be taken and um how much. I think I was talking to a developer who was trying to or going to incorporate 20% manure just to kind of balance out the system, and over 80% of that digester go into food waste. And there are, systems that take 100% food waste. And as far as the types of food waste, a lot is possible. Not, I mean, it really depend. It takes some level of kind of filtering out to see what works, but especially for food processors, depackaging equipment has come a long way in making a lot of different packaged goods work for digesters, and a lot, especially I'd say the most easiest ones to incorporate. There's probably produce and other foods like that, different meats and that kind of stuff. Kind of adds a lot of sulfur, which brings up a few concerns about odor and that kind of stuff. But generally speaking, it's a pretty wide range of foods that you can incorporate.
Great. And the follow-up is, do they pay a tipping fee for food waste?
Yes, that is kind of one of the biggest selling points for farms to partner because, yeah, a lot of times, landfills have this tipping fee, and digesters, given that they're actually making productive use of this, can kind of undercut them and claim, a lesser tipping fee for these taking off their food waste.
Okay, a couple more questions here. It says, I understand that for larger operations, several farms are transporting waste to a centralized farm digester. Are there additional liabilities for the farm hosting the digester?
Um, I would say just for these agreements, there is one kind of for farms, you're usually going to have kind of an agreement to then get some digestate, which is used kind of to replace the manure as part of your fertilizer. So that might impact, the nutrient management plan and how, the nutrients going into because digestate, the nutrients are a little bit more available. So if you're claiming trying to get digestate back from that digester, there are things to consider about that, that nutrient difference, as well as, just really thinking about that agreement to provide manure, what are the clauses, what are kind of the risk if, say, something happens and you can't get it there for some reason, thinking about who's responsible for that offtake, what even the kind of condition that the manure needs to come in, what kind of solid to liquid ratio they're looking like, does that affect your operation in any way? So a few things there to consider.
Okay, a couple more questions here. It says, how do you discuss concerns regarding nutrient runoff? Has there been any support from environmental organizations connected to the Great Lakes and watersheds?
Yeah, and that's definitely a great question. So I think a few things are first, a lot of it comes down to proper management of kind of the digestate, just like it is for manure. So, I mean, I'd say oftentimes what I've seen is farms partnering might shift to an injection system, which works really well for digestate, kind of making less of an opportunity than, say, broadcast. So, injection is kind of putting it more directly into the soil versus broadcast, which is throwing it on top, which can really reduce the nutrients we see runoff on these systems. So that's always an option. Digestate is a little bit more can be applied at very a little bit has a better ability to be applied at different times, so you can emphasize when you apply it in conjunction with, say, cover crops to reduce that runoff concern. But we've actually done some work here on the Sea Change project on looking at potential solutions for, this nutrient concern. And one of the biggest ones is maybe just nutrient collection and making it a product that can be sold, therefore kind of removing a lot of nutrients you might see and reducing that any kind of risk.
Okay, two quick more questions. Says, is there a threshold in size, I'm assuming the digester size, that triggers federal permitting?
Yeah, I don't think I guess yeah, I don't think there's anything size related, there is, DEP, EPA permitting, which is kind of on the state federal side of things, mainly state. But as far as size goes, unless you're in a state that has an energy siting board, um, you might see projects either be handled more at the local level or state level for some levels of siting permitting, but generally speaking, there isn't really a size requirements that factors in more federal permitting as far as I'm aware.
Okay, and last question, and if you could actually work in, you had some digester owners, I guess, at your event recently, and what they're doing around community smell, so impact. So, what are there any negative community reactions due to smells, plastics, or anything else? And how are the owner operators managing that with the community?
Yeah, so in practice, especially if you're just using manure, like digesters actually reduce odors. We actually have a digester on state campus that the first time I drove there, I thought I was in the wrong place because I saw like Beaver Stadium, you know, just across the road, and I was like, "Oh, how could they get away with it?" But, digesters, generally speaking, do reduce odors. Now, if you, depending on the food waste and how you manage it, that is where some problems could occur. I've seen digester operators operate on a really piping system for food waste that always has it contained, which can reduce any kind of potential odors you might see. Not all food waste is that much of a problem. Other digesters have gotten away with just what food waste they use. And, a lot of it is just potential sulfur contents in that food waste might bring up odor concerns after the digest state is stored. But generally speaking, you're going to see a large reduction, and we are seeing digester operators also take seriously things like PFAS and plastics in trying to screen kind of these food waste products for these kind of issues, as well as, finding ways to kind of filter that out as they can.
Okay, great. We didn't stump you on any, and that's all the questions we had. So I appreciate that. And so again, thank you to everybody who attended today. I did drop the link in there, and if you want to download the report, as well as take a look at some of the other reports that we have on our website. So with that, again, Matt, thank you for your time, your expertise, and thank you for everyone joining us today. Have a great day.
Yeah, I appreciate being here.